this is, you can take that as the second part of this talk.
Okay.
And also what I plan to propose next week in our discussion with Professor Chella. You see, what we have here already is how to handle procedure knowledge in NARS. That is, for every operation, you try for the system to learn its precondition and consequence. Okay, and also as well as, of course, the uncertainty related. That is, how often under that condition, if you do this, you're going to have that result. And what it will give us, this thing actually can be further developed into several directions. And one thing we can say is, for example, how is this related to robot? We haven't done anything about robots, but you can see the operation we are talking about can clearly be robot operations. Okay. So every robot from a theoretical point of view is defined as a set of operation or action it can take, the basic action. Okay. What makes current robot kind of like stupid or without intelligence is the overall reaction is basically most of the time is a routine. That is, you already have those operations organized into a phase sequence which will be triggered by a certain signal. Okay, you press this button or you make this sound or something, then it will do, for example, operation number 1, then followed by operation number 3, then followed by operation number 7, and then it's a fixed sequence. So what we can do is we are going to break this sequence back into the individual operations, and then use the NARS reasoning system to learn. For example, if you have your robot is nothing but to us it's just 20 operations. That's your kind of like API. Okay, we're not going to do a direct program those API. Instead, the first step is going to make the system to try to learn for each of the operations by itself. Under what condition, what can be achieved? For example, clearly there is operation just to move the arm, okay, in this way. Another one that move the arm in this way. And another one move the arm in this way, another one just move the leg or the way or whatever. So we don't care about the physical detail. We just, to us, each of them is just, it's a operation has a name or a sequential number. Okay, we will just say, under condition number 1, if we do operation number 5, we are going to observe result number 7, something like that. So here is what makes it slightly different from this picture is, again, is under some condition, if you carry out this operation with some parameter, you are going to see a consequence. But what makes this robotics situation different first is this one, of course, is a command to a body of that robot. But as well as this one, for example, how do you know a certain condition is satisfied or a certain consequence have been achieved? They are also operations. These are more like the sensational operation or perceptive operation. It's kind of like if you focus your eye on this direction, you're supposed to be able to get this signal back. So see, that's another thing we mentioned before. That in NARS, perception is operation. You don't sit there and wait for things to come into you. You do things, you use your eye to see, you use your ear to hear. So that's related to our previous point, and that is, we also want some kind of like operation probably to be here or to be here. But still we may want to somehow keep this difference between this type of operation and this type of operation. So that's kind of like the sensational operation, there's no operation, but it is different from that kind of like that operation or the action operation, right? So you can control your eye, you can control your leg, but they're different. Because when you control your eye, the most important part is what you get as the feedback, then which you take as your sensational perception. When you control your leg or will, What really matters is the change it causes. It makes you move to a new location or you change the other stuff in the environment and so on. But the result is still obtained through some kind of observation, which is also operation. So you'll see the first thing we may want to achieve by connecting NARS with a robot is to get this kind of stuff. So especially we want to kind of like form, in psychology they call it sensory motor coordination. That is, when you do this, you're going to see that. Okay, so you see this is very different from the traditional theory about your knowledge. This is not a knowledge about the world. It's to a large extent, it's a knowledge about yourself. That is how to coordinate your sensation with your action. Okay, that's, of course, that's also within the current environment. The environment will provide restriction about the relationship. But still, it directly is about, if I see this, I do that, I'm going to see that. It's something like that. So I guess that's kind of like the first step. Okay, if we can obtain a lot of those things. Just by, for example, for the system to play, just randomly try to, kind of like push its own button, see what will happen, that kind of model. At the very beginning, you see this kind of thing can be built by this kind of mechanism. But at the very beginning, most of the things that it observed will actually caused by accident. It's just, you do this and the light happen to be on, but it's not really caused by you, but by someone else. Press a button, but you don't know that. You think it's because of this action, which somehow magically triggered the light. But later, if you repeat that, it's not going to happen again, so you know that's false. Okay, so this is again related to the thing we discussed about top law of conditioning. Some of the hypotheses will be disqualified by accumulated negative evidence, but some of them will turn out to be true. That is, for example, if I move forward, my visual field always changes in a certain way. Okay, something looks closer, some picture become larger, so that's an important part of my sensory motor coordination. So I will see, if I turn my head, what will happen to my visual field. So that kind of thing can be learned, basically using the mechanism that we just explained. It just now we have a more concrete situation that's in a robotic setting. So that will be step number one. Step number two will be related to planning and self-programming. That is, okay, if I do operation one, I know this will be the case. Then this one may happen to be the precondition of our operation two. Then I will know that if I do operation one followed by operation two, just by pure simple deduction, I should be able to guess what's the consequence. Okay. So if I know, I move here, I will be in a new location. If I press this chair and this chair, according to my knowledge, it will move in that way. So if I combine these two steps together, I know what to expect. So that will be a very simple program, which is nothing but a compound operation. But you can make this chain longer and longer and longer, then the computer should be able to program itself in the sense that it should be able to form a certain combination of operations, which in principle can exhaustively achieve all the possible goals as far as it can be achieved by the combination of these operations. So the difference will be directly related to what we mentioned before about creativity. Okay, you don't program the computer at once. You let it try by itself. So maybe at the very beginning, some of the success is obtained just purely by coincidence. It just happened to be lucky it worked, but it will be remembered. right? It will be remembered just as what Patrick said, and then this will be repeated again and again and become a stable pattern. So in the future, whenever I want that kind of thing, I will just do this. What if something I've never done before? We can do reasoning, for example, by analogy. We will, at least this is similar to something I have achieved before. Okay, if this thing is unrelated to anything I know before, of course I'm completely hopeless. But usually it's not that bad, it's somehow related to something we have achieved before. So we can do analogy, we can do that similar thing, then we make some small adjustment here or there by adding additional operation into the sequence. So it's basically, again, this is different from some other machine learning mechanism. We do not completely try random combination of operations. Okay, that is quite a limited approach. There's just too many possible combinations for you to try, and some of them actually can kill you. It can be dangerous. So we use reasoning to make a prediction before we actually move. But again, we need to try it to get the feedback to know for sure whether it works or not. Sometimes you plan pretty well, but in reality, there are factors you haven't taken into consideration, then you're in trouble. But in NARS, it's okay, we use that as negative evidence. Then we'll try something else. Then I think this two steps, at least we already know, conceptually speaking, what to do. First is to just establish procedural knowledge about the operation of the robot. And the second is to form compound operations based on what we have. What we don't know, one thing is we don't know how to compile that compound operation into one single operation, even though we know in theory that's possible. It's just like in human programmers, okay, you do hierarchical thinking, where you think in terms of big chunks, then you build, you kind of like divide it into smaller and smaller pieces. And here it's more like, if I have a sequence which is pretty stable, then I give it a name. And also in the interface, I only mention the parameter which is kind of like open to the outside. Everything else will be kind of encapsulated within. So that's what programming is all about, right? This step, we still need to figure out the detail. What else? Backward reasoning perfectly fit into this. We have a goal and try to divide it into sub-goals, and each of the sub-goals can be achieved by operation, which is we already know how to do, and then we just put them together. So that part is already available. So anyway, that's one thing we are going to talk about and see what they think about. What we are going to ask them to provide is an API of a robot. Then typically at a much lower level compared to the existing API. Every robot, there will be an API already. It's basically about more about the routines that robot can do. What we ask is a more kind of like smaller unit of that. So what do you do? Well, I don't want that. It's kind of like I don't want a complete grab operation. Instead, I want to be able to access how to move each individual finger. And I may want to use a different approach to combine them for new skill. Okay. But on the other hand, of course, we can also keep the current routine for something, just routinely can be routinely achieved. So what we can add new is, in principle, they have that combination, that possibility, but they haven't figured out how to code it into a complete routine. So that's where probably we can make a contribution. So that's for robot in general. For this guy, for this Professor Chella, his favorite topic is not just robot, but conscious robot. Okay, where did that come from? That actually is also in the future. That is where this operation is not oriented to the outside world, but to the inside world. So it's basically the same picture, but here we are going to talk about the mental operations of NARS. We already have that in a book, all right? That's what this level 9 is all about. But we don't have all of them in the code. Do we have anything from level 9 in the code?
I guess some operations like want, believe, consider, anticipate,
Okay.
I think evaluate, some mental operations we have.
But they're not really used, right, in the code. It's already there. We haven't been able to use it.
Oh yes, the only mental operations that are used currently are want, and believe, and oh yes, and
Do we use mental operator for anticipation?
it's supported, but by default it doesn't generate the operation.
Okay.
But it's.
But which one is currently routinely used?
The want and believe.
One, okay, it's wherever you get a new question, and you also generate that. Yeah. So clearly the mechanism is already conceptually there. We haven't done a lot of testing, but it's the same idea. And first, we may want to do some experiment, especially to hook the mental action to the mental sensation. It's kind of like, if I fail this, I want to do that. But that is done within my mind, myself. And this will be directly related to sensation of emotion. If I don't feel good, what should I do? Yeah, that's something we need to think about. So anyway, again, I think the idea will be in this pattern. It is the mental operation related to mental sensation. You need to know what's your current status to do something. But a new idea, which I haven't really write in my book, but I have been thinking about, is the current mental operation is kind of like isolated or separate from the actual routine of the system. Now I'm thinking one thing we can try is to actually, the current working cycle, you know, very roughly speaking, select a concept, select a task in the concept, select a belief in the concept, and do a reasoning to produce a new task, and put a new task back, and then you just repeat this process. That's the working cycle, right? Conceptually speaking, each of the steps I just mentioned can be a mental operation.
So that we generate a consider event whenever a concept is selected.
What's good about that? You also want that to enter your event back in the same way as your sensation from the outside world. It's just like you have an eye, you see what is going on. Now you have an inner eye, you directly sense what is happening within yourself.
To some degree, this is already happening.
Yeah.
For instance, if the happy, the satisfaction event and the busy event is already entering event back.
Yes.
And the operations are already handled.
Yeah. Now I'm thinking about whether we want more of them to happen in that way. So in this way, you see part of the sensation will be an internal sensation which tell you what is going on inside yourself. And for example, when you get a conclusion, you can ask the system, okay, at the current moment you can get a conclusion whereby it's an answer to a question, for example. I give you a question, you give me an answer. The current model can do that. But it cannot answer the question like, where did that thing come from? Okay, if we have this mechanism, we can directly answer that because we do have a memory. Like again, that's exactly the same idea as the structure. you see, if I get this conclusion, I know the event that happening before it. And those events are nothing but my mental operations. Okay? When I'm thinking about table, I happen to be happy for some bizarre reason, I don't know. But if it happens again and again and again, you see, I'm going to control myself in a certain way to achieve my goal. So it's nothing but self-control, right? In a very basic form.
Sure.
So, yeah, again, there are a lot of details to be filled in, but as a first step, I think instead of trying to define some new fancy mental operator, why not we just turn the current internal major operation itself into a mental operator and let the system to control that. Which is perfectly consistent with the philosophy we have been using so far. It's just one more step, I guess, in that direction.
That's interesting.
And then that will naturally lead to, for example, use emotion as the guidance. I want to be happy, and in the past, if I think about this, I will be happy. If I think about that, I will be sad. So in the future, I will try to avoid that type of thinking. I will just.
That's interesting.
Yeah.
We should try that, I guess.
That's basically what currently I have in mind, and I will think more and have a better, more organized material to present next week, and see the response from our friends. Comments?
I was wrong about the anticipation operation.
Mm-hmm.
It's already generated.
Mm-hmm.
So the system predicts something. It will multi-generate the operation, anticipate.
Mm-hmm.
So in this case it's already happening.
Yeah.
But we don't have something for consider. And
Yeah.
maybe it's
Yeah. Also, we need to decide what's the name of each of them, but that's secondary. The first, the primary thing is, what kind of thing we want to expose to the reasoning system. You see, clearly you don't want your mind to control everything in your body because there's just too many of them. You don't want to be consciously control your temperature, for example, or your blood flow. Okay, but you do want to control something, especially your part of your thinking process. But which part, I think at least we can say the major operations. If we can say that, then basically we can say the system can change its train of thinking according to its own decision. Yeah, of course, sometimes it will cause some strange loop. Okay, if I'm thinking about what I should be thinking about all the time, then I will be in big trouble. But some of those thinkings will be necessary. For example, you should be thinking about what is the most important thing for you to think about in the next, say, hour, rather than let your thought to just flow freely.
we are mostly taking the position that almost everything should be a form of procedural perception, self-control.
Yeah, yeah, because this is perceptual by nature. It is procedural by nature. As far as it's not just a description about the situation. If it's as far as it's action you're taking, then the knowledge related will be procedural knowledge. That is mostly about the precondition, and when you can do that, and what will be the consequence. Then your reasoning will be about planning or predicting. If I do this, what will happen? You need to think about that. But this is not just the physical thing you do to the world, and also in your mind.
What if categorization is also some kind of procedure learning, like for instance that we learned that cats are animals? Is this something probably also caused by a sequence of mental operations?
Of course it is. Because you see, in a sense it's already, I think we will still keep this data-driven nature of reasoning. That is, as soon as you pick your premise, you effectively pick your inference rule, right? Because that's the only a certain inference rule that can be triggered. So I don't think we should go this far to say, okay, I want to do induction, I want to do deduction. I think that's probably not a good idea. But you can say, okay, now it's time to think about go home. Okay, that will trigger a whole bunch of other inference. Anyway, you guys still have a week to think about this. Then next week we will have a big discussion. And